Hello students, Assalamu alaikum. Actually, the purpose of this screen recording is to just introduce you differentiation, although only last part of finding nature of a stationary point, whether it is minimum or maximum, was left in the last class, but I thought it should be discussed again, and I should discuss in a very short video how you should get a differentiation equation, and then how to find out the turning points, and how do you check the nature of the turning point with the help of differentiation. So first of all, differentiation, you should remember the formula. Like if we are given a function f of x as x to the power n, then f dash of x, it is treated as derivative. So n, the power of x, becomes the coefficient of x, and original power was reduced by 1 unit. So this is how differentiation of any term is done which is involving x to the some power. So if I apply this approach for the other case of y equals to x to the power n, if this is the case, then you should apply derivative in this way: dy by dx equals to n times x to the power n minus 1. This is the same thing in different formats. When f of x is given, you should write f dash of x as derivative function. If it is given y equals to some x to the power n, then the same approach is applied. Whole power, original power goes in the coefficient, and 1 is subtracted from its original power. The same formula is applied, but the thing is, you should express your derivative now as dy over dx. Dy stands for very small change on y corresponding to a small change in x. So this is actually how I introduced you in the beginning of this lecture. Now, how do you solve the question? One more thing that is important here: if I check derivative of a function which is some constant like 3, so f dash of x becomes 0, because derivative of a constant, of any constant, is always 0. Why it is 0? Because if I try to put x to the power 0 as constant coefficient, constant is left outside the derivative, as I told you in the last class. C multiplied by 0, then x to the power 0 minus 1. This 0 multiplied with both of them, it makes everything 0. So final answer comes as 0 as per formula. Or if you try it with the help of a graph, y equals to C is a graph of a horizontal line, and as I told you when I introduced dy by dx, it is nothing but gradient of the function. So gradient of the function is 0 if it is a horizontal line, because it's actually parallel to x-axis. So its slope or its gradient is 0. No change in y as compared to change in x. If you change values of x along x-axis, 1, 2, 3, 4, 5, value of y is not changing here. So no change in y as compared to change in x. So there is no gradient of this line. That's why graphically you can understand it this way, or directly you can apply it this way. When constant comes with the variable part, like y equals to 3x square, this is the original equation, and we have to find the derivative. How we find it out? First of all, we apply our derivative operator d by dx on both sides. This way we apply it, d by dx, but it is applied only on variable part. The constant or the coefficient goes outside the derivative. See, this is the difference. If there is only a single constant in term available there, its derivative becomes 0. But if constant comes along with the variable part, that variable is already there in the coefficient, then it is left outside the derivative and it's applied to the variable part only. So in this case, it becomes 3 is left as it is. X square becomes 2x, because original power 2 comes in coefficient and 1 power is reduced, so it becomes from 2 to 1. So 2x is the derivative of x square as per formula of y equals to x to n, derivative is n times x to n minus 1. So this becomes 6x finally. So this is actually applied on y. So if I write it in this way, this dy by dx, this becomes dy by dx on left hand side, on right hand side it is differentiated, so finally it is appeared as 6x. See, so this is how you find out derivative function. I think I should solve one question for your and more understanding of this concept. I am going to solve one question, complete question, in which we find out the gradient function and then we find out the turning points of the function and then nature of the turning point. Let's take some example question here. Example question: f of x is given to us as x cube minus 3x square minus 7x plus 4. Let's suppose this is the original function. What we have to find f dash of x, means derivative function, or we have to differentiate this function and find its gradient function. Gradient function or derivative function is the same thing. Second thing is we have to find the stationary points on this curve of y equals to f of x. And the third thing, find the second order derivative function and state which one is maximum and which one is minimum point on curve of y equals to f of x as given in this question. So first of all, we should apply formula of differentiation. F of x equals to x cube minus 3x square minus 7x plus 4. So f dash of x means derivative function is simply applying d by dx operator on right hand side. And now we have to split it into all terms. It's applied to all terms. D by dx of x cube separately minus this 3 and x square are coming together. So as I did in the previous example, you see 3x square, I left 3 outside and applied derivative on x square only. So similarly I just leave this minus 3 outside and apply this derivative on x square term, and then minus 7 is similarly left outside and derivative is applied on only x. And then in the last term there is a single constant only, no variable part is available. Or you can leave 4 outside and apply derivative on x to the power 0. You get the same answer. Of course, for constant it always comes 0, because when you multiply with this power 0 in numerator, from power to the numerator, it's always 0, because 0 multiply anything is 0. This is why derivative of constant is always 0. So it becomes 3 times x square minus 6 times x minus 7. This is cancelled and this is 0, so that terms is x exempted from here. So f dash of x is coming as a quadratic equation, you can see. For cubic curve, like equation number 1, equation number 2. Cubic curve, y equals to x cube minus 3x square minus 7x plus 4, or f of x equals to x cube minus 3x square plus minus 7x plus 4. It's a cubic equation, so its derivative is coming quadratic. In the previous example, what I use a quadratic equation, my derivative was coming as a linear function. So you should understand that every time we are actually subtracting one power from original power, so its degree is dropped by 1 unit. So for degree 4, obviously you can guess your derivative function must be cubic. For cubic, derivative function is quadratic. For quadratic, derivative function is linear. So always we have 1 degree lesser in derivative function. After finding this, we have to find out the stationary points in the second part. This first part, as I did. For second part, I have to find out a stationary point or a turning point. Turning point or a stationary point is the same thing as far as your syllabus outlines are concerned. Actually, I'm trying to save all this stuff on single, that's why I'm just reducing the size of it and I'm placing here and there. So only single slide, 1 page description would be enough for your quick revision. Now come to the next part. So we were doing stationary point. Okay, for the second part, we can differentiate it again. Sorry, we can consider that for stationary point, we consider gradient function as 0, because gradient of the turning point, as it's a cubic curve, so it's like this. It has 2 turning points. The original curve is a cubic equation, as you see. This is cubic. There's some kind of curve like this, which has 2 turning points. One is maximum, the other one is minimum. And at the turning point, if you take the tangent to the curve, it becomes horizontal. So dy by dx becomes 0 at turning point, or f dash of x is 0. So for turning point, f dash of x is equated to 0. So if I substitute this value of f dash of x in equation number 2 as 0, my equation becomes 3x square minus 6x minus 7 equals to 0. So this is now a quadratic equation. So you can find out the 2 possible values of x from here by using quadratic formula, or if factorization is possible, you can use factorization method by breaking the middle term, or you can directly apply the formula of x equals to minus b plus minus under root b square minus 4ac upon 2a minus negative 6. Negative 6 is value of b, plus minus under root negative 6 square minus 4 times 3 into minus 7 upon 2 times 3, 6 plus minus under root of 36 plus 3 4 is 12, and when you multiply 7, 14, 84 plus 84 divided by 6. I think I should use a calculator to solve this expression further. Square root of 84 plus 36 is 120. So 6 plus minus under root 120 divided by 6. Square root of 120 equals to 2 root 30 plus 6. So we have two answers, 6 plus 2 root 30 divided by 6 or 6 minus 2 root 30 divided by 6. This is actually 3 plus under root 30 divided by 3, and this is 3 minus under root 30 divided by 3. If I take out common 2 and cancel it out in the denominator, this is the exact value, but we need decimal answer. So in decimals it is coming 2.8257. I just write 2.83, 3 significant answer here, or 3 minus under root 30 divided by 3. That gives me negative value of minus 0.83, minus 0.8257, so it's minus 0.83. So we have two possible values of x. One is the smaller value I am writing first, minus 0.83 minus 0.83, and other value is 2.83. We have two possible values of x at which turning point is coming. One is negative, the other one is positive. So basically this is the curve. If I focus on this curve, if I place my axis over here, my y-axis is coming somewhere over here, which is giving me at negative 0.83 and at positive 2.83. So we have two turning points. One is lying at negative 0.83, the other one is lying at 2.83. But these are not maximum or minimum values of the function or stationary values. We have to find out stationary points. So we need to know corresponding values of y as well. So substitute these two values in this equation 1, this one, x cube minus 3x square minus 7x plus 4. So that will give you the answer of the turning point, or y coordinate of the turning point. I think I should resize this whole stuff. Still readable, okay. Now I can just substitute these values in equation number 1. So equation number 1 implies that y equals to negative 0.83 whole cube minus 3 times negative 0.83 square minus 7 times negative 0.83 plus 4. This will give me the value of y, which is corresponding to this value of x. So I just substituted these values here. negative 0.83 cube minus 3 times negative, always substitute value in a bracket, okay, 0.83 squared minus 7 times negative 0.83 plus 4. This comes as positive answer 7.17. So this is corresponding value of y corresponding to at x equals to negative 0.83. So the turning point is minus 0.83 comma 7.17. This is one turning point. Let's suppose this is turning point A. And now I can find out the other point at x equals to 2.83. Similarly, I can find with the help of equation number 1 y equals to y equals to 2.83 whole cube minus 3 times 2.83 squared minus 7 times 2.83 plus 4. You can see equation number 1 and you are substituting here and just using this equation, so just reference should be put earlier and then implies that sign should be placed, and then you have to put the value in the equation and then you have to finally conclude your answer. So in the same expression I am just changing my answers from negative 0.83, I am replacing it from 2.83. So this is coming minus 17.17, so I am writing minus 17.2, and this answer is coming negative. Let's suppose this is second turning point, which is coming at 2.83 along x-axis, and minus 17.2 is the value of y. So we have two turning points here. These are two turning points. Turning point one, and this is turning point number 2. So this is how we find out turning points. By the way, one more thing I want to add here for your information. If it is asked in the question to state the maximum value and minimum value of the function, it means only value of y should be stated instead of the whole turning point, because the graph is plotted for the quantity along y-axis, just like velocity time graph is for velocity, not for time. So quantity on y-axis is actually value of the function. Okay, so if it is required to state the stationary values of the function, then only state 7.17 and minus 17.2 as stationary values of the function. Okay, these are two stationary values. I think I should state here these are two stationary values. Stationary values. These are stationary values. Okay, only y coordinate are the stationary values, and its stationary points or turning points are paired values of x and y. Hope you understand that. Now, how do you check whether it is maximum or minimum? By the way, you can simply see this one is positive value and this one is negative, so this one is maximum, this one is minimum. But this is not the evidence of it. There is some mathematical evidence that is to be provided with the stationary points that you certainly assure that this is actually a minimum point, this is actually a maximum point. And how do we do it? I told you in the last class as well, but I am repeating here because I am concluding each and everything in one slide here for this chapter. Now I am going to do the next part of the question. Find the second order derivative. So we find out second order derivative here. Second order derivative is d square y over dx square or f double dash of x. In this question I am dealing with f of x, so it's better to use the symbolic notation of f double dash of x. So how I find out f double dash of x in this case? Simply applying derivative operator d by dx on both sides, but here f double dash of x is already written, so need not to show here, just only show it on right hand side along with the equation of f dash of x. Means I am differentiating f of x again. So f of x is 3x square minus 6x minus 7. So now I am going to differentiate derivative function f dash of x with respect to x again. So how it is differentiated? The same method. This coefficient 3 is left outside, this derivative goes to x square only, then minus 6 is the coefficient, so it's left outside, d by dx is applied on x only, then minus 7 is left outside, d by dx is applied on x naught, because x to the power 0 is there in the constant term, and if I differentiate it, power comes in numerator, so this 0 is multiplied with these two things, so it will make it 0, so you can ignore this term, it's 0. I think I should mention here, this all stuff becomes 0 because it's single constant. When single constant comes, its derivative of 7 is 0. So you can ignore it and just differentiate the rest two terms, because derivative of 7 is already 0, so need not to add here. Now this x square becomes, according to the formula, it becomes 2x, and when it is multiplied with 3 it becomes 6x, and then this dx cancelled, so it's simply 1, and this is 0, so plus 0 is unnecessary, but if you want to mention you can. So 6x minus 6 is my final answer of f double dash of x, or second order derivative of the function. This is my second order derivative. I can call it equation number 3 because the original function I nominated as equation number 1, derivative equation I nominated as equation number 2, means first order derivative. This is actually first order derivative, first order derivative, and this one is second order derivative. And remember one thing, second order derivative is just for the assurance of maximum and minimum points. Which one is maximum? Show that this is maximum, show that this is minimum. So in only that case you have to go for second order derivative. Unless it is required in the question, you should not differentiate it again. Okay? So first order derivative is enough to find out stationary points. But just to make it sure that it is maximum or it is minimum, you have to take second order derivative. Okay? Now you should try these values of x which are giving you turning points and fit them in this equation number 3 or as second order derivative equation. F double dash of minus 0.83. So 6 times minus 0.83 minus 6, it is something negative. 6 times negative 0.83 minus 6 is coming minus 10.98, which is less than 0. So if f double dash of x of negative 0.83 is coming less than 0, therefore maximum exists at x equals to negative 0.83. So it is shown that maximum is lying here, and you can see 7.17 is bigger value and minus 17.2 is a smaller value. Now you can try second value as well at f double dash of 2.83. 2.83. My third equation of second order derivative gives me 6 times 2.83 minus 6 as positive answer of 10.98. Since f double dash of 2.83 is greater than 0, therefore minimum exists at x equals to 2.83. This is shown actually. Okay, it's verified here. That's it. This is all about the whole discussion of derivative or differentiation in your syllabus. Whether you call it derivative, or differentiation, it has the same meaning. Second order derivative is shown by d square y over dx square, and you have to differentiate the derivative function itself. So I think everything is discussed on one slide. Now I'm going to share it in Google Classroom as well, and I'm going to share its link as well, so you can have a look of it and you can revise the whole topic. And last exercises, last 4 exercises, 2 or 3 exercises, sorry, of chapter number 7 are based on this concept, so you can practice questions from there just to get prepared for your mock examination and your final examination. Thank you, students. Take care. Allah Hafiz.